I'd like to do a couple more examples of rationalizing denominators using conjugates just to make sure that you're really comfortable with this concept. So example 5, let's say that I have 4 over 2 minus rad 3. I look at my denominator, recognize that I need to get rid of this radical, so I'll multiply top and bottom by the same terms. I just change the middle sign. So I say plus radical 3. 2 plus radical 3. I start with that denominator. First with first, 2 times 2 is 4. Outer, outer, inner, inner always cancels out. Positive times a negative, guaranteed will be a minus. And rad 3 times rad 3 is just a regular 3. Now 4 minus 3 is 1. So it means I won't have an opportunity to cancel with anything that's up here because 1 goes into everything. So I'll go ahead and distribute this 4 across these two terms. 4 times 2 is 8. 4 times rad 3 would be 4 radical 3. And an equivalent form to this, I really don't need to say it's over 1. This is equivalent to just saying 8 plus 4 radical 3. If you want to have the 1 there, it's fine, but you don't need it. Let's do another example. We'll call it example number 6. Let's say we had 3 rad 5 over 2 rad 3 minus, I don't know, 4. Just making these up. So I multiply top and bottom by 2 radical 3 plus 4. 2 radical 3 plus 4. Notice how I always put my parentheses around the original denominator as well, so it sets up my FOIL. This is really what you're going to need to practice with. When I look at this, I have to go the free with free, so 2 times 2 is 4, and just remember that's 4. Rad 3 times rad 3 is regular 3, so I've got 4 times 3, which is 12. You may have to do that off to the side as I did earlier. You may have to write 2 rad 3 times 2 rad 3, where your 2 times 2 is giving me 4. The rad 3 times the rad 3 is a regular 3, and then I'm multiplying that. So I'm doing all that in my head. That's how I get that 12. Now I come back to the FOIL concept. So I did first with first to get 12. Outer, outer, inner, inner always cancels out, has to, minus automatically. 4 times 4 is 16, which means that I have a negative 4. 12 minus 16 is negative 4 for my denominator. I don't have an opportunity to cancel there, or at least it doesn't appear so at this point. So I'm going to go ahead and distribute. I'll go 3 times 2 is 6. Radical 5 times radical 3, not enough to get anything out of the radical, so this becomes radical 15. Plus 3 times 4 is 12. Radical 5. So I bring this down. And I always have to inspect my answer to see if there's that opportunity to cancel. And what I'm looking for is all or none. Do all 3 of these pieces have something in common? They can all be divided by 2. So I'm going to divide this 6 by 2 and get a 3. Divide the 12 by 2 and get a 6. Divide this 4 by 2 and get a 2. Which means an equivalent form to this could be 3 rad 15 plus 6 rad 5 all over negative 2. Once again, here's an opportunity to talk about how, like on a standardized test, a multiple choice test, you might work a problem out and then that not be one of your options. You are expected to be able to identify equivalent forms. An equivalent form for this would be when I take this negative and distribute it across the top. So maybe I would write negative 3 rad 15 minus 6 rad 5 all over positive 2. Note how each and every part just changed signs. I'm not asking you to do this in your homework. I'm asking you to be able to recognize it if you see it again. If you see that you've worked a problem out and your answer isn't matching any of those options, especially like on con or standardized test, you may have to look at that and go, oh, I see they took the negative and they distributed it across the top and then made the negative on the bottom become a positive. So they basically borrow this negative, take it to the top, and distribute it. Let's do one more example here, and then I think we'll be pretty good for using conjugates to rationalize denominators. So let's call this example 7. And let's do another one that has that rational and radical part. So let's say we had 4 radical 3 over 2 radical 5 minus 3 radical 2. So the easy part here would be that we're going to multiply by the same terms. All we do is change the sign. 2 radical 5 plus 3 radical 2. 2 radical 5 plus 3 radical 2. And let's see what happens. I'm trying to get you to do this in your head. So I'm going to do the free with free part. 2 times 2 is 4. Radical 5 times radical 5 is 5. So I'm looking at 4 times 5, which is 20. Minus automatically. Outer, outer, inner, inner drops out. As I look with the last with last, 3 times 3 is 9. Rad 2 times rad 2 is 2. So this is 9 times 2. 9 times 2 is 18. 20 take away 18 is just 2. I don't know if I didn't leave myself enough room to do that. I'm looking at a 2 in my denominator versus this in my numerator. This does give me an opportunity to cancel here. So I can take this 2 out and cancel this 4, call that a 2. Now it would just be a matter of distributing what I have up here across the set of parentheses. So 2 times 2 is 4. And then the rad 3 times rad 5 is rad 15. And we reboot. 2 times 3 is 6. Rad 3 times rad 2 is rad 6. And so I get 4 rad 15 plus 6 rad 6 all over 1, which would just be, in simplest form, 4 rad 15 plus 6 rad 6. So we got 7 examples on how to rationalize denominators using conjugates. Hopefully that helps you out.